All right, guys, welcome back. We are going to be jumping into our next section here. We're talking about the distributive property, which hopefully is not new to you, but let's go ahead and take a look. So here's a chart explaining the distributive property, and I'd like you to go ahead and pause and copy this down, and then I'll talk about what it means. So here we have some different things that we got where I have A times the quantity of B plus C, and you notice that that translates over here to AB plus AC, or we have the same thing with the A right here on the back end, but it means exactly the same thing. Now, when I initially teach distributive property, when I used to be in 7th grade, I used to always tell my students to put these little things right here. And I always referred to those as rainbows. And I don't know, I have a strange way of thinking of things, but I used to think, well, B and C are, they made some bad moves. Those dudes are in jail right here. And every good friend's going to bust his friend out of jail, so, which isn't true at all, but for the sake of my math story, let's just go with it. And so everybody knows the best way to get somebody out of jail is you throw rainbows in the windows. So I used to always refer to these as rainbows, and I'd say, let's get these guys out of jail. And how are we going to do it? We're going to throw a rainbow to every... So the rainbow is really intended to help you to remember that you multiply everything inside the parentheses by this A. Hence the A times B and the A times C. Or down here, this is a rainbow in the back door, B times A and C plus A. And it works the same thing with the subtraction here. Here are some numerical examples. Hopefully you got those copied down. So let's see how this plays out. But first, just a moment of truth. Real friends get down on their hands and knees by the urinal. Yeah, that's big time right there. I wish I had a friend like that. Okay, so simplifying expressions. It says, what is the simplified form of each expression? So this first one, again, to simplify, there's not going to be any parentheses in there. So I'm going to use the distributive property to multiply everything inside these parentheses by 3 to get rid of those parentheses. So this is 3x plus 3 times 8, and then I could simplify 3 times 8, which leaves me with 3x plus 24. Now, ideally, you do this a few times, you start noticing that this is a pretty easy problem. Like, you don't necessarily need to write out 3 times 8. If you could go straight from here to here, that's great. That's my preference. But I will caution you, the one mistake that I see students make a lot is they would do 3x plus 8. They forget to multiply that second number by the 3, which is why I like the rainbows. All right, let's go over here. Here we have some backdoor rainbows going on. So here I have 5b times negative 7 minus 4 times negative 7. Now this one's a little bit uglier looking than that other one, but it's not impossible. This should look like the stuff that you just did on your quiz, where we use the commutative property and associative properties, and we could actually multiply this thing out. And we get negative 35b. And over here, notice that if I kill subtraction to make that negative, I have a negative times a negative, which means this becomes a positive, so I get positive 28. Negative 35b plus 28. And I need to include my equal signs. All right, so here's a couple for you to try. Take a moment and pause and do those on your own. When you're finished, hopefully you got 5x plus 35. And on this one, hopefully you got 1 2/10 plus 3 3/10 c. If you didn't get those, go back and try to find your mistakes. All right, here, so rewriting fraction expressions says what sum or difference is equivalent to this. First thing that you need to remember, and this is from our order of operations section, is that anytime you have a fraction bar, whatever's on the top in the numerator or whatever's in the bottom can be considered to be inside parentheses. So this 7x plus 2 is inside parentheses. The other thing that you have to think about is, well, I'm dividing by 5. What am I going to do about that? There's a couple ways you could approach this. First way is to understand that dividing by 5 is the same thing as multiplying by 1/5. Now here's a really easy example of what I mean by that. If I take 4 and I divide 4, let's do a better number. How about 6? If I take 6 and I divide 6 by 2, that equals 3. If I multiply 6 by 1/2, which is called a multiplicative inverse, That also equals 3. So dividing by 2 and multiplying by 1/2 mean the same thing. If I come over here and I do 6 times 1/2 and I follow my rules for multiplying fractions, I have 6 times 1, which is 6, over 1 times 2, which is 2. And you should remember that that fraction bar means division. So this says 6 divided by 2. And that is why multiplying by that fraction is the same thing as dividing by whatever that denominator was. In this case, it's 2. So how does that apply to this particular problem? Well, if I come over here and I look at this, I'm dividing by 5. So this is going to be the same thing as distributing a 1/5. It's the same thing as multiplying by 1/5. All right, so this is equal to this, and then I distribute this. So here I have 1/5 times 7x plus 1/5 times 2. And then I'm multiplying some values here. So 1/5 times 7x is 7x over 5, or you could do 7/5 x, that's the same thing. And then this right here is 2 over 5. But one thing you got to be careful here is when you get these fractions, if there's anything in here that could simplify, you must do that. So 7 and 5, their greatest common factor is 1. 2 and 5, greatest common factor is 1. You can't simplify anymore. But be careful on this next problem where it's a u-try, because there may be something you have to simplify. All right, so go ahead and pause and try that problem on your own. Hopefully when you're finished, you get 5/4 plus 1/2 x, or you might have x over 2. That's the same thing, and that's perfectly fine. Hopefully you found these things that simplify. If not, go back and try to figure out what it was that you did not do correctly. All right, so here, using the multiplication property in -1, this is super easy. It says, what is the simplified form of negative, and then this thing in the parentheses? Well, first of all, you got to remember what that negative sign means. If I have -4, what that negative sign means is take -1 and multiply it by 4. What is the opposite of 4? Well, it's the -4. These two things are the same thing. This is one of those properties, multiplication property of -1, that you saw a couple lessons ago, but this is how it plays out. For this particular problem, I'd read that -1 instead of that negative sign, and then I would go through and I'd distribute that -1 to everything inside the parentheses. So I'd have -1 times 2y, which is -2y, and I have -1 times -3x, because that minus sign goes with the 3x, and that becomes a positive. Now, if I'm comparing these two expressions, the expression inside these parentheses to this expression, notice the difference here. Here it's just the opposite. Here it's just the opposite. So anytime you have a negative in front of the parentheses, you're multiplying everything by -1. But when you do that, it means you're going through and you're changing all of the signs of the different terms. So here's one for you to try. Go ahead and try that out. And hopefully after you're finished, you found x minus 31. Should not be too difficult for you. All right, so here's some vocabulary terms. Pause and write these down. These are important because I use them all the time, and you need to start using them too. A term is a number, a variable, or a product of a number and one or more variables. In other words, there's no addition or subtraction or division within a term. A constant is a term that has no variables. In other words, it's just a number. A coefficient is the numerical factor of a term. In other words, if I have 3x, the 3 is the coefficient. Like terms have the, it should say, exact same variable factors down to the exponent. All right. In other words, I may have something that is a 2xy and something that is 3x squared y. They both have x's and y's, but this one has this squared right here, so these are not like terms. You have to have exactly the same exponents. In order for them to be like terms, they both would have to have that x squared. All right, so combining like terms is really simple. We could go through this and show some mathematical stuff, but hopefully you learned this in 7th grade. So for the sake of time, I'm just going to go through. You're basically adding the coefficients. So 8 plus 2 is 10, and then you keep the variable with its exponents. Here we have multiple terms, and what I like to do is I like to draw pictures around things to help me remember. So I'm going to put a box around all my x's. Always include the operation in front of the term because that's its sign. This is a negative 3x. There's no other x's. I see a constant right here, so I'll put a loop around those, or a circle. And then the only y I have is right here, so I won't even do anything with that. So next thing is I'm going to combine all of my ones that are in boxes because they're like terms. 5x and negative 3x is positive 2x. I have negative 3 and positive 4 is positive 1. And I didn't have anything to add with that 6y, so that just comes down like that. So hopefully you found those to be no problem. Here's some you-try problems. Go ahead and give those a shot on your own. All right, when you're done, hopefully you found this first one to be 2y. Be careful because this y right here has an assumed coefficient of 1. All right, there's an assumed coefficient of 1 right there, and that's an easy mistake for students to make. This one right here, they have exactly the same variable makeup, so I could add those. It's a negative 7 plus negative 5, so that's negative 12 mn to the 4th. Down here, this has 7 cubed z, this is our 7y cubed z, and then this is y cubed z as well. So these are like terms, but notice this one has a y and a z, but it's not the exact same variable, so those are not like terms. This has my assumed coefficient of 1, so this is 8y cubed z minus 6yz cubed. And hopefully you didn't have any problems with those. That's it for today's lesson, so I'll see you guys in class. Come ready to work.